Right now, you are likely holding a device that contains more computing power than the entire NASA agency possessed when they landed astronauts on the moon in 1969. But here's what nobody tells you. To build this thin slab of glass and metal sitting in your palm, human civilization has to tear open deep mountain mines across 4 continents, blast raw rock with thousands of degrees of heat, and manipulate atomic structures inside clean rooms cleaner than a hospital operating theater. Imagine taking 16 different elemental metals, burying them under tons of molten sand, and forcing automated hyper-robotic arms to align components to a margin of error smaller than a single strand of human DNA. Most people think their phone was just assembled in a sterile modern factory over a few quiet hours. The reality is a brutal, high-stakes global battle against time, physics, and toxic chemical limits. Think about this for a second. Before you ever tap your touchscreen to send a simple text, elements inside that device travel a combined total of over 300,000 kilometers across oceans and borders. We are about to step inside the most secretive manufacturing network on Earth to see how raw rock turns into pure technological magic. And what happens at the very first step of this journey surprised even experienced engineers. Our journey doesn't start in a sterile laboratory with white lab coats. It begins deep underground in the dust, heat, and roaring diesel engine noise of open-pit mines in the Democratic Republic of Congo, Chile, and Western Australia. Deep beneath the Earth, miners extract raw cobalt and lithium, the volatile elements required to power your phone's battery. Cobalt raw or must be crushed, washed, and chemically treated through acid leaching to reach an extreme purity level of 99.9%, while raw lithium brine is pumped out from vast salt flats under scorching 40 degrees Celsius 104 degrees Fahrenheit heat and evaporated for up to 18 agonizing months. To build a single standard smartphone weighing roughly 170 grams, workers must extract and process over 34 kilograms of raw rock and earth. That is over 200 times the final weight of the phone itself. We depend on rare earths like neodymium and dysprosium mined in Inner Mongolia to make your speaker vibrate and your haptic engine buzz. These rare elements cost up to $300 per kilogram, requiring refined extraction through hazardous nitric acid solutions where single impurities, measured in parts per million, can ruin an entire production batch. And here's a supply chain secret most people never know. The ultra-pure silica sand required to create the silicon wafer heart of your phone's processor comes almost exclusively from specific quartz quarries in Spruce Pine, North Carolina. This sand is shipped thousands of sea miles to specialized foundries in Taiwan, where it is melted at staggering temperatures exceeding 1,900 degrees Celsius 3,452 degrees Fahrenheit. The environmental footprint of shipping raw ores across 6 oceans before assembly creates millions of metric tons of carbon emissions annually. If a single link in this globe-spanning chain breaks, or if a single country restricts mineral export, global phone manufacturing halts completely within 48 hours. But raw minerals are useless until they undergo a transformation so violent that it requires the heat of a miniature sun, and that brings us straight into the factory fire. Step inside the semiconductor fab, a clean room pressurized to 1.5 bar with filtered air so clean that a single particle of dust per cubic meter would trigger an instant facility shutdown. Here, pure silicon ingots are sliced into ultra-thin wafers using diamond saws spinning at 10,000 revolutions per minute while bathed in cooling oil. These raw wafers are placed inside extreme ultraviolet photolithography machines costing over $150 million each, burning circuit lines onto the silicon using laser light pulse 50,000 times per second. Simultaneously, in a separate wing of the facility, giant sheets of aluminosilicate glass undergo an intense chemical toughening bath. The raw glass sheets are submerged into a molten potassium salt bath at precisely 400 degrees Celsius 752 degrees Fahrenheit for up to 8 hours straight. Through a process called ion exchange, smaller sodium ions in the glass are forcibly replaced by larger potassium ions under extreme thermal pressure, squeezing the surface glass together into a diamond-hard armor shield capable of surviving drops onto hard concrete. Now, watch the printed circuit board assembly line accelerate to a blinding mechanical scream. Automated surface mount technology pick-and-place machines fire microchips onto the board at speeds exceeding 80,000 units per hour, placing microscopic capacitors with an accuracy tolerance of plus or minus 15 microns. The boards then pass through a multi-zone reflow oven heated to exactly 245 degrees Celsius, 473 degrees Fahrenheit, for 180 seconds. Melting solder paste to permanently lock tens of billions of transistors into position. The scent of hot resin and vaporized flux fills the factory floor as human operators dressed in anti-static gear sit alongside 6-axis robotic arms to attach the camera modules, lithium-ion battery cells, and delicate ribbon cables. Every human worker performs their assigned task within a strict 45-second cycle window before the conveyor belts move the chassis to the next station. But here's what nobody tells you. Despite the staggering mechanical speed and precise engineering, nearly 5% of all completed phones fail the moment they face the terrifying gauntlet of quality control. Welcome to the torture chamber of modern technology. Before any smartphone leaves the factory floor, it must survive testing conditions designed to simulate years of extreme physical abuse in just a few hours. Automated pneumatic testing rigs slam completed phones onto steel plates from heights of 1.5 meters, repeating this drop test up to 200 consecutive times from every possible angle. Over an environmental chamber, phones are frozen down to a freezing minus 40 degrees Celsius, minus 40 degrees Fahrenheit, before being instantly blasted with hot, humid air at 85 degrees Celsius, 185 degrees Fahrenheit, and 95% humidity for 48 uninterrupted hours. High-pressure water jets blast the seal casings from all directions at 100 bar pressure to verify the IP68 water resistance rating. Meanwhile, AI-powered computer vision systems equipped with 100 megapixel sensors inspect every square millimeter of the screen display, instantly rejecting any panel showing a defect as tiny as 2 microns, far smaller than a single red blood cell. Yet, even with millions of dollars invested in artificial intelligence and precision camera scanners, there is one critical moment where human skill beats machines every single time: the final optical camera alignment check. Master human technicians sit in absolute darkness, adjusting microscopic camera lens barrels by hand while looking at laser calibration grids to ensure crisp focus that automated AI software simply cannot replicate. If a batch shows a defect rate higher than just 0.01%, the entire 1,000-unit production run is instantly quarantined and scrapped, costing the manufacturer hundreds of thousands of dollars in minutes. The tension inside these facilities is electric, because these factory floors are feeding a global consumer appetite that never sleeps. And when you look at the sheer numbers driving this industry, the scale becomes almost impossible to comprehend. Consider the staggering reality. Global factories produce roughly 1.4 billion smartphones every single year. That means every single second, 44 brand new, fully functional smartphones complete their manufacturing journey and drop into retail packaging. The total market valuation for this single product category exceeds $500 billion annually, a financial footprint larger than the entire gross domestic product of most developed nations. China leads global assembly with over 65% of all devices produced, followed rapidly by India at 16%, Vietnam at 10%, South Korea, and Brazil rounding out the top 5. Direct manufacturing employs over 3 million line workers worldwide, backed by an estimated 10 million workers throughout the raw supply chain. Think back just 50 years ago. In 1974, a mobile phone was a heavy brick weighing over a kilogram that cost $4,000 and offered just 30 minutes of talk time after 10 hours of charging. And this is where it gets truly extraordinary. Over the next decade, projected advances in flexible solid-state batteries, 2-nanometer chip fabrication, and recycled ocean plastic frames will completely reshape every factory floor on Earth. Did you know that there is more gold in 1 ton of discarded smartphone circuit boards than in 17 tons of raw gold or extracted from the Earth? Did you know that the vibration motor inside your phone spins a tiny off-center tungsten weight at 11,000 revolutions per minute, faster than a commercial jet engine turbine? Or that the glass covering your lens is sapphire crystal polished using diamond slurry for 7 days straight? When you combine raw earth, extreme physics, hyperautomation, and thousands of hours of human engineering into one pocket-sized device, it becomes clear that we are holding something far greater than just a piece of consumer electronics. Which brings us back to the device sitting right in front of you. We have traveled from deep, dark mines in the African heat, through ultra-precise Taiwanese cleanrooms, past roaring high-temperature ovens, and through brutal destruction test labs. Every single component in your pocket is a quiet testament to millions of human beings and machines working in perfect synchronization across borders, languages, and oceans. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.